To overview the agenda of what we'll be talking about today, first I'll go over the architecture of IMDb and quickly outline some of the major components that compose IMDb. Then we'll discuss how IMDb fits into the framework of COM+10 services. We'll discuss some common usage scenarios that we envision IMDb to fit well into. And then we'll spend a majority of the last half of this talk going over some simple Visual Basic and ADO code samples that illustrate how IMDb is utilized. IMDb will be shipping as part of Windows 2000. It is part of the COM+10 services and is installed by default as part of the Windows 2000 setup. By default, it is not configured to start up, and that needs to be configured by Component Services Administration Tools, which we will cover later. COM+10 components utilize IMDb through the familiar interfaces ADO and OLEDB. In addition, we also introduce a new interface called TSPAM, or Transacted Shared Property Manager, which we will discuss at the end of the session as a demo. But to give you a heads up, that is a new interface that provides shared property groups in a transacted and cross-process functionality. First major component of IMDb is the IMDb service, or also referred to as the IMDb server, which has the main responsibility for managing locks and writing to data that is contained in the shared IMDb cache. The IMDb service is communicated to by what is referred to as IMDb proxy DLLs, which will run in process with COM+10 components. In order for COM+10 components to communicate to data which is in IMDb cache, IMDb exposes MS-IMDb, which is an OLEDB provider. MS-IMDb exposes sufficient OLEDB interfaces so that it supports ADO as well. Both ADO and OLEDB can communicate to the MS-IMDb OLEDB provider. We provide support for seeked, range retrievals, sorts, and filters via indexes created in IMDb cache over tables brought into IMDb cache from SQL Server and Oracle databases. In addition, IMDb can also be used as an intermediate store for information created solely within IMDb. In order to enable this, IMDb supports OLEDB and ADO DDL statements so that temporary tables and indexes over these temporary tables may be created in IMDb cache. It is easy to build IMDb COM+10 components via C++, Visual Basic, Active Server Pages, and Java. We'll now go over a series of diagrams that help illustrate how the major components of IMDb interoperate. The IMDb service is the main component which performs communications with SQL Server and Oracle databases when those tables are loaded into IMDb cache. In the case, there are two ways that IMDb cache can be populated. In this diagram, we'll cover the situation where IMDb is configured to load Oracle or SQL Server tables at IMDb service startup time. In this case, the IMDb service at service startup time will read information from a back-end table and then has a responsibility for loading this information into shared memory, where it will be accessible by COM+10 components. An alternative to loading information at service startup time is for the COM+10 components to control the loading of the table data into IMDb cache from backend databases, so that it only loads at when the information is requested from the COM+10 component. In this case, the component which runs the IMDb proxy DLL in process will make a call to open a record set over a SQL Server or Oracle table which has been defined to be connected via IMDb. Once again, the IMDb service is the component which talks to the SQL Server or Oracle table and will populate the information into IMDb cache. Note that the difference was that this can be done from the IMDb proxy and dynamically after the IMDb service has been started. We'll now cover the situation and talk about how IMDb reads information from the IMDb cache. In this situation, we've already covered the table population. Now we will note that HTTP and DCOM clients call into COM+10 components located on the application server.
Just a quick interruption. The countdown slides are now, the IMDb slides are now reflected in that directory. They had a 0 byte value, but now I've updated it, so.
Oh,
so.
Wonderful, thank you. Should I repeat that with the camera?
Probably got it.
Okay.
Sorry, everyone.
Okay. The COM+10 components, in turn, run IMDb proxy DLLs in process. For the maximum amount of performance, in the case where IMDb components are only reading from the IMDb cache, no interaction between the IMDb proxy and the IMDb service needs to take place. Reads are done in process in the COM+10 component directly out of IMDb cache and returned to the component via the IMDb proxy, which is running in process. This results in very high performance reads. Now let's discuss how IMDb writes to SQL Server or Oracle databases. Once again, HTTP or DCOM clients communicate with the COM+10 components. In this situation, when we would like to write to information in IMDb and SQL Server and Oracle, the IMDb proxy needs to send a request to the IMDb service component requesting an update to that table. The IMDb service, in turn, will be the component which controls locking and controls the actual writing of the data into that table in IMDb cache. At the same time, the IMDb service component also controls how the information is written to the SQL Server and Oracle table. Hmm. 64-bit memory provides the opportunity for databases to store, or applications to store, a much greater amount of data into cache than was available in 32-bit to 32-bit applications. In order to take advantage of this architecture, IMDb transparently accesses 64-bit memory for 32-bit applications. Developers utilize OLEDB, ADO, and TSPARM interfaces with IMDb like they normally would. But IMDb transparently under the covers will automatically make use of VLM or very large memory APIs in order to cache data into a larger memory space if that VLM architecture is available to it. Currently, there is support for VLM on the digital alpha architecture. To illustrate this, We note that a 32-bit application normally has access to 32-bit memory space, which at the moment has a maximum size of 3 gigabytes on NT platforms. By the same 32-bit application taking advantage of IMDb, the client application now has the ability to cache information if it's using IMDb in a much larger 64-bit memory space. On Digital Alpha, that would increase the size of the potential data cache up to 23 gigabytes, potentially holding much larger data sets. Note that the client application does not need to move from 32-bit to 64-bit pointers in order to take advantage of this larger memory space. If it chooses to use IMDb, it is IMDb that transparently takes care of the 64-bit pointer work for the client application. Now we will discuss how IMDb fits into COM+10 services. IMDb leverages the COM+10 transactional infrastructure. Developers that would like to use IMDb within COM+10 components need to set components into the transaction required setting in order for those components to perform updates into IMDb. That is applicable whenever IMDb is utilized to update SQL Server or Oracle tables. We provide one exception to this. When IMDb is utilized as an intermediate store and there is no SQL Server or Oracle table related to the table cached in IMDb, we provide a high performance write option just to that intermediate data. We refer to these operations as write-through operations. This allows non-transactional COM+10 components to write into an IMDb table without requiring a transaction. We envision this useful for scenarios where it is important for a complex component to stream data very quickly and write it into cache such that other components have visibility to that data immediately, which is the reason we provide write-through operations. Much more detail about write-through operations has been added to the Beta 3 Platform SDK documentation under Component Services Programming Help. So please look at the Beta 3 Platform SDK for more information on write-through. In the case of reads, and at the default isolation level of IMDb, which is read-committed, transactions are not required for components, and that includes data that is brought in from SQL Server and Oracle, or temporary data, which is held just in IMDb. IMDb leverages Microsoft Distributed Transaction Coordinator in order to provide the ACID properties to our transactions occurring to components using IMDb. Component Services Administration admin tool is a central tool for providing most of the operations that are required for administering IMDb. This would include IMDb startup properties, such as the number of megabytes that IMDb initially allocates, selections such as whether or not the IMDb service will dynamically or statically load SQL Server and Oracle tables, and other features. IMDb security is also administered mainly from the Component Services admin tool. The IMDb trusted user role, which we'll talk about in a few slides, is used to provide or to control access as far as which accounts have access to IMDb cached data. It is a requirement to set up IMDb data sources in order to control which Oracle and SQL Server tables are loaded into IMDb cache. Starting this and stopping the IMDb service is easy from the Services section of the Component Services admin tool. And we also provide centralized troubleshooting information under the application log of the event viewer. One of the main parts of IMDb administration is deciding which tables to cache. IMDb supports full table population from SQL Server and Oracle databases, so that is one of the decisions, and we'll talk a little bit about that in IMDb planning. Note that the back-end SQL Server and Oracle tools are the tools utilized to create indexes that will be mirrored in IMDb. By that I mean IMDb, when it loads a SQL Server or Oracle table, it first reads the metadata from that table. And from that metadata, it will create the same indexes that were created on the SQL Server or Oracle table, and then create them onto the equivalent data in IMDb cache. So it is advantageous to take advantage of tools such as SQL Server Index Tuning Wizard to make sure that the indexes on your backend table are also what you need in the case of IMDb, because that will preserve that performance benefit when you bring the data into IMDb cache. This screenshot illustrates some of the major features of the Component Services Administration tool. For example, the IMDb Trusted User role, which is a complex application role located under the My Computer icon and the System application. As we see, by default, IMDb service is not enabled to start up by default, but it is required to check the IMDb enabled checkbox in order for the IMDb service to run. Also by default, the IMDb memory size option is by default set to 0. That will mean that IMDb will allocate as much memory as possible on the Windows 2000 server while leaving a sufficient amount of memory for IMDb to run. While that may be fine in situations where IMDb is the only component running in on the Windows 2000 server, we recommend that if you have other applications which are memory intensive, such as Internet Information Server running on the machine, you will want to plan your IMDb memory size to be just sufficient to hold the number of tables that you will have in IMDb. Also, there's an opportunity to check whether you're going to load tables dynamically or not. Also underneath the IMDb, cursor will not show, okay. Thank you. I try to describe more clearly where I would have put my cursor as I'm circling here. Underneath the, also underneath My Computer, and there is an IMDb Data Sources folder, which contains data sources for all of the Oracle and SQL Server databases that will need to be or database tables that will need to be loaded into IMDb cache. In this situation, we've selected a IMDb data source, and its name is Henry L _IMDb. There are 4 text boxes which are required in terms of specifying what SQL Server or Oracle table to load. In this case, the first text box, named OLADB provider name, specifies one of 3 OLADB providers which may be used by IMDb. In this case, we used the SQL OLDB provider, which is the Microsoft OLADB provider for SQL Server. It supports 6.5 and 7.0 databases, SQL Server databases, and we recommend SQL OLADB as your recommended provider when speaking to SQL Server 7.0 and 6.5. Also possible in this text box is the MSDA SQL provider, which is the Microsoft ODBC provider or OLADB provider for ODBC, which can be used such that ODBC, Oracle, and SQL Server drivers can be used to load information into IMDb. But and a third option is MSDA ORA, which is the Microsoft Oracle OLADB provider. The next text box is the provider data source. In this case, it is filled with the local specifier, which means that is talking to this IMDb data source is talking to the local SQL server on this Windows 2000 server. The next box is referred to as IMDb catalog name, and it indicates the SQL Server database which is being connected to, in this case, the pubs database. In the last text box, we provide a section for provider properties being passed in to the SQL OLEDB provider. In this case, we provide authentication information with the UID being equal to the SA account and PWD as the password. We'll speak about this a little bit later. IMDb also supports integrated security. If this was an integrated security situation, this provider property would be blank. And this allows security to be defined as far as writing to the database and writing to IMDb by the security access of the COM+10 component and the accounts accessing that COM+10 components. And IMDb will utilize those credentials for connecting to the data sources and writing to the data sources versus using this provider property string. Under the Event Viewer folder of the Component Services Admin tool, there is the Application Log Event Viewer. IMDb will log informational error and warning messages into this section. I've shown here an example on the slides of one particular event, which is a normal informational event from the IMDb server. It indicates information such as the fact that the Henry L_IMDb data source successfully initialized and loaded. There is additional information that you can log into a text file, and we provide the information to configure this logging of information in the Component Services Administrative help file. That help file can be accessed by going to the Component Services Administration tool and choosing the File menu item Help. Under the and in the Administering IMDb section of that help file, you'll find ways to log additional information and how to set that up on the IMDb service startup properties. For example, in this text file, we see additional information such as the amount of megabytes that IMDb server started with, and the data sources that were loaded, this particular SQL Server tables associated with the IMDb data sources that were loaded, which indexes from the SQL Server tables were successfully recreated, and which tables were successfully populated from SQL Server into the IMDb cache on the application server. IMDb leverages the COM+10 security infrastructure to provide its security. The way we recommend that IMDb access be configured in terms of security is to depend on the access rights of the users that are accessing the COM+ application and the COM+10 components. Because IMDb supports integrated security, it'll be able to leverage those access rights lists and utilize those for how and which user accounts can access SQL Server and Oracle backends, as well as information inside the IMDb cache. As a security planning methodology, you should plan to run the IMDb service under its own account. And we recommend that the service, the account running the IMDb service, only be provided with read-only access to either SQL Server or Oracle databases that it communicates to and loads into IMDb cache. The IMDb service, by default, does not require that it have anything besides read-only access to load tables from SQL Server or Oracle. By providing the account running the IMDb service with only read access, it allows you to separate what the IMDb service is able to do and permits you to control write access to your SQL Server and Oracle database tables via integrated security and only allowing user accounts running COM plus 1.0 components, separating ones that you wish to be able to write to SQL Server tables from certain other accounts calling COM plus 1.0 components that you may not want to, and allows for that division if you use integrated security. The IMDb Trusted User role, which is a COM plus application role, is provided to control which accounts can access the IMDb cache itself. In this case, we recommend that you formulate a Windows 2000 domain account group and load that group into the IMDb Trusted User role. This provides a methodology for administering who can access IMDb from Windows 2000 groups. As we mentioned before, the principle is that IMDb supports integrated security, so you should separate client accounts that can update Oracle and SQL Server tables in terms of which accounts communicate with COM plus 1.0 components, and leave the account running IMDb service, the IMDb service, to be read-only for Oracle and SQL Server. Now we'll go over some of the common scenarios that we envision IMDb to perform well in, and try to tie that back to what Mary talked about in the last session in her Margie's travel scenario. First off, in this slide, we'll talk a bit about why we envision people would use IMDb. In the Windows DNA architecture, if you see a situation where the business layer is repeatedly reading an identifiable set of data, it makes a lot of sense to place that data into a place closer to the COM plus components that require it, and to make that access to that data as rapid as possible. By doing this, it helps eliminate trips to the database. It also would be nice, and this functionality is provided by IMDb, it would be nice to eliminate out-of-process calls in order to retrieve that required data. IMDb helps out in this scenario by performing high-performance in-process data reads. The net result is that it's possible to build more scalable COM plus 1.0 components if this data is identified from SQL Server and Oracle databases and placed into IMDb. Another advantage of IMDb is it provides industry-standard database APIs, being ADO and OLADB. This provides customers with the opportunity of replacing proprietary caching schemes with IMDb. Many customers already implement proprietary caching, but usually the knowledge of these caching schemes is limited to a small set of programmers who originally implemented and developed the caching. By moving that caching to IMDb and utilizing OLADB and ADO, the knowledge of the caching mechanism for application server code has been expanded to all programmers in the industry that are familiar with ADO and OLADB. Here's a traditional three-tier scenario where we envision IMDb to be useful. On the middle tier, COM plus 1.0 is utilized to develop components for the application server. In this case, we see IMDb and envision it being used to cache data that is read quite often on the application server. By staying in the read committed isolation level, reads from that identifiable set of data will be in process and very fast. In addition, at the read committed level, IMDb does not need to provide any locking on that data due to the architecture of IMDb. When a COM plus 1.0 component can retrieve information from IMDb versus having to go to the database, the network activity is reduced by one network hop. We see IMDb as providing the most performance benefit in this scenario by keeping critical information on the application server and keeping that information closest to the COM+10 components. The next scenario discusses version 1 situations where we have multiple COM+10 application servers. Potential scenarios would be very large web scenarios where it is a requirement that there be several application servers participating in order to provide the required scalability and performance for a situation. And in this scenario, it may be a requirement that a single SQL Server or Oracle table has been identified as being a very hot table or repeatedly read. IMDb could be used in this scenario if it has been identified that the SQL Server table or the Oracle table that needs to be on the middle tier application server is read very often by the middle tier, but the refresh of the data, it is not a requirement that the refresh of the data be more than every night. In other words, it's not a table with which it is required to do heavy online transaction processing to that table. And the benefit of the read data is more from the fact that it's less fresh as far as every night or every week. In this case, IMDb in version 1 provides an opportunity for there to be performance benefit by treating each of the IMDb caches on each of the multiple COM+10 servers as read-only. And in order to provide refreshes to the IMDb data, we utilize dynamic table loading in configuring the IMDb service and set up another COM+ object which uses either OLEDB or IMDb DDL commands to drop the table out of IMDb cache and then quickly open a row set on that table to reload the data. So many customers have asked when we'll be able to support updates as well in this scenario. Now in version 1, we will support this type of scenario. In order to have another scenario where each of the IMDb nodes can update to a single table that came originally from SQL Server or Oracle and is capable of updating that in IMDb, having that change persist to SQL Server or Oracle, and then pop or transfer that change so that it's consistent across IMDb caches. We will provide this functionality, and we are working on that in terms of providing this functionality, which is referred to as coherent caching in future versions of IMDb. But we feel that in version 1, we still provide a lot of benefit, especially in the web scenarios, by utilizing IMDb in a read case for identifiable data sets that are heavily read on the middle tier by applications, by using this method. And by using this method, we provide a natural migration path to future IMDb when we do provide coherent caching on the IMDb node. By utilizing this methodology, it's very natural by implementing with IMDb version 1 now to move to coherent caching later. And later on, you'll just have to remove the COM objects that do the drop table and open row set, because the coherent caching will do that naturally for you and during the day as well, as new transactions are populated to the IMDb table on any node. The third scenario we'd like to talk about is using IMDb more as a temporary caching store to increase performance of your COM+10 application server components. We give an example somewhat like the MS Market scenario, where we have a shopping cart that you're doing processing on. intermediate information is held in IMDb. In the scenario, the information that needs to be written to the database is usually the final information about the order. But in order, there is also intermediate information as this order is being processed. It is only when it is finalized that you need to transfer it to the database. So to help with this scenario, intermediate information can be stored in IMDb. When the information is finalized, the COM+10 components can quickly read the information back from IMDb and write that data independently to whichever backend it's communicating to. The performance benefit here is that by using IMDb to maintain intermediate state, intermediate trips to the database from the components are avoided. The TSPAM interface, which we mentioned a little bit before, can also be a benefit here in simpler dataset situations. TSPAM provides simple name property pair values, or it can be organized in terms of groups of properties with their matching value for each property. If state information is such that it fits into this model well, then TSPAM, which we'll talk about in the last demo of this deck, might be well suited for this purpose within a COM+10 application. Now, to fit in, or to try to tie into Mary Kirkland's scenario from before, in the Margie's travel scenario, we're going to talk about 3 points where we think IMDb may provide a lot of benefit. IMDb, given that many web scenarios are heavily oriented towards the read case, there's a big opportunity to insert IMDb into web scenarios where the data which is read quite repeatedly by a website can be identified and placed into IMDb cache, whether it be from SQL Server or Oracle tables, or whether that be some other type of data that became created dynamically and loaded into IMDb. For example, in the Margie's travel scenario, items such as customer preferences or such as broadcast messages that go out to many customers that need to be read fast can be provided through IMDb so that COM+10 components used on the web servers can quickly access this information, and there's no reason why that information cannot be read in the read committed level, thereby allowing reads without locking overhead and in process with COM+10. Also, much like the state scenario that we just described, in the Margie's travel scenario, each customer or traveler will have intermediate information that they, in the form of what their travel plans are. And until that is finalized, that intermediate information could be held in IMDb. And when that is finalized, it can be, the component can take that as a very efficient single batch and send that to the database in question. So we'll talk a bit about what's involved in planning for an IMDb deployment. The most important issue is determining which backend tables need to be loaded. There's a decision, depending on whether what type of scenario you choose to deploy IMDb in, as to whether tables will be loaded dynamically when the information is requested, or whether they'll all be loaded statically at service startup time. It is worthwhile considering reducing the amount of data in the SQL Server and Oracle database prior to loading it in IMDb. If the usage requirement for that data on the middle tier is considerably different from that where it will be how it is used on the back end, it's worthwhile to consider reducing both the number of columns and the number of rows prior to moving it into IMDb, so that indexes can perform even faster over the data as it's cached, and that there is less data to navigate over if it is unnecessary. IMDb is a completely in-memory solution for caching data. So it is important to make sure that there is enough physical memory loaded onto the server to handle all of the tables that you've determined would be valuable in IMDb cache. It's also important to consider that the usage of the IMDb data may be different from what it was used for in SQL Server and Oracle. That being the potential case, we provided the ability with ADO and OLEDB in IMDb to create additional indexes on IMDb data, and that might need to be taken into consideration if the data access patterns are different. It's worthwhile to note that IMDb does require an index on sort and filtering operations, and that will ensure that good performance is provided. And like I said, ADO and OLEDB can be used to create these indexes over data that's cached in IMDb. IMDb is optimized for the read case. As we've noted before, read committed, which is the default isolation for IMDb in complex components, works the best because there's no locking involved. Lock management has been based upon the architecture of the SQL Server 7.0 lock manager, but it has been optimized for the memory-only case. And for best performance, we recommend that C++ and OLEDB be used for complex 1.0 components that will be using IMDb for maximum performance and scalability. Now what we'll cover is a few simple Visual Basic and ADO samples that illustrate how IMDb is utilized and give you a little bit more understanding into how to implement with IMDb. First, the creation of temporary tables and caching data. As we mentioned before, IMDb can create the temporary tables and indexes that will not be stored in any Oracle or SQL Server backend, just for use in complex 1.0 components on the middle tier. The first part of this slide shows what needs to be done, and unfortunately I don't have a pointer, so I'll read. First off, in the line using the connection object called CN, which is a new ADO-DB connection, we simply need to treat the IMDb as any other OLEDB provider and connect to MS IMDb and load that as a provider property. We then open the connection, and then IMDb provides support for the ADOX catalog object, and in order to provide or the ADO 2.5 extensions for table creation. So we declare TB, which is a new ADOX table object. We fill in the properties with tb.name. We fill in the name for our new table in IMDb, and we then need to just populate the columns collection for that table object by adding some simple columns with ADO data types, as we would normally do in any ADO program. Then what we need is a primary key on that table object, so we declare a variable key y as the ADOX key object, and we indicate that it's going to be an AD key primary to load a primary key on column 1 into the columns collection of the key object. We append that key object into the keys collection of the table object, and then we take that table object and append that to the tables collection of the catalog object CAT that we declared up as an ADOX.catalog object. And that is all that is required in order to create a temporary table called temporary IMDb table into the IMDb cache, load it with 3 columns, and place an index on it. Now that that table has been created in IMDb cache, on this slide we show that it's very easy to then use a record set object, RS, which we declared as an ADO record set in the previous slide, and utilize that record set as we normally would with ADO to load some data. We set that RS to have an active connection on CN, which we opened previously. And the source of the record set is set to be the name of our temporary table, which is temporary IMDb table. The cursor type that we are going to open is set to be AD Open Dynamic, so that we can update on this IMDb table, and we set the locking to be optimistic. Then all that is required on the record set is to use the open method, and we use the add new method to create a new record. Then we just, after we create the new record with add new, all that's required is to fill the 3 columns that we know to be part of our record set, and then add literal values, equate those columns to literal values as we see on the lower part of the slide, whether it be integer values or date values or string values. And then we just call the record set update method in order to put that data into IMDb cache. The same methodology would be used whether you're using a temp table or whether this was an IMDb table that was loaded from SQL Server or Oracle into IMDb cache. If that were the case, you would use exactly the same program and instead connect to an IMDb data source that was associated with a SQL Server or Oracle table. In our next example, we will show how IMDb reads from a SQL Server database table. It's actually easier if we start from the next slide, which is the ActiveX DLL implementation, and then we'll go back to the calling program and show how that's done. In Visual Basic and ADO, we implement an ActiveX DLL, and in this case, that simple DLL, all that it exposes is the public function that we call as fetch. The fetch method returns as a result set, or returns as a result, an ADO record set, and this record set being from IMDb. As we see, all that we need to do is declare 2 variables, CN as our ADO connection and RS as our ADO record set object. The connection object is set again as the provider, MS IMDb, as our OLADB provider. And for the connection string, as we saw in previous admin slides, we previously declared the IMDb data source to be Henry L _ IMDb. Once it has that information, we simply open the connection object, the CN object, and set the record set active connection to that CN object. So we've talked about how the ActiveX DLL is implemented. So now we'll see how easy it is to call into that ActiveX DLL from a standard, in this case being a standard Visual Basic EXE using Visual Basic and ADO. All you need is a record set object and declaring Visual Basic object. We use the create object call, and we know the name of the object we created to be that string literal name, which is simple DLL1.simple IMDb DLL. We fire up that object, it instantiates it, and at that point we can grab a record set from it because we know that the OBJ object that we have exposes the fetch method that we saw in the previous ActiveX DLL implementation. We set our record set in this calling program to just be the return value of that fetch method, which we know to be the record set of the ADO record set that we just created in that fetch method, which is the SQL Server table that is defined by the IMDb data source Henry L _ IMDb. Once we grab that record set, we can do all of your regular ADO typical operations on it. For example, in the next line, we do an rs.sort, which is, oh, it's okay, we're back on the calling guy, thanks. For example, we do rs.sort, sorting the information by the information in column 2, COL2, in descending order. For example, we show a little bit of a loop here where we're populating a Visual Basic list box with the contents of the record source. And we're just doing a do while. We create a string variable, and we populate that string variable with the contents of column 1, rs exclamation mark col 1, and append to that the converted string value of the rs exclamation mark column 2, which we know to be an integer value. And then we just add it, keep adding it to the list box. And all we're trying to show here is as simple as your regular ADO operations. That is what you can do with information out of IMDb, whether it be from the DLL or manipulating inside the DLL as an ADO record set or an OLIDB record set. Okay, the next slide. And the next slide after that. Oh, thank you. Okay, next. Now we'll show our next example, or last example, we'll show and talk about Transacted Shared Property Manager. Okay, next. First we'll talk about what TSPAM, or Transacted Shared Property Manager, is. Okay. Transacted Shared Property Manager is a new evolution upon the Shared Property Manager that many of you are familiar with from previous COM releases. Now, Transacted Shared Property Manager, as you might imagine, has been expanded so that it provides cross-process and transaction-capable properties organized into property groups. And we provide new interfaces so that it makes it easy to use TSPAM inside your COM+10 components. Okay? In fact, TSPAM, although it's a separate interface, in fact, is implemented underneath via IMDb, so the transaction semantics are similar to what you would see in IMDb. Okay, next. Okay. TSPAM is organized into, first of all, there's on the top of the hierarchy, there's a transacted property group manager. Each transacted property group manager is capable of creating a transacted property group, and you could have sets of property groups. And within each transacted property group, each group may hold one or more transacted properties. Okay, next. Each transacted property may hold a single variant value. Okay. And security options, unlike SPAM, security options can be set on all the objects within TSPAM, or all of the TSPAM objects. Okay. So now we'll just walk through a simple example how you would use TSPAM in Visual Basic and ADO. In this example, we just have an ActiveX DLL, which exposes the create group method. All that's required is to define a variable. For example, in this case, starting off, defining a variable which is from the TSPAM object, which is Transacted Property Group Manager. We declare that first of all. We also need to declare TPG, which is a transacted property group. We need the set TPG. This is a typo on this particular slide, but I've updated that as of last night so that you will see on the slide drop point the updated TSPAM sample. So then you just set TPG equal to the TPG.createProperty group, providing the name of the group and the other 7 required properties, including security and other options. Okay. Oh, okay. Thank you. We're back to me flipping the slides. Then after you've successfully created the property group, all you would need to do is create then a transacted property, or TSPAM property, which in this case we call TP as a new transacted shared property or transacted property. In that TP variable, we used hanging off of the TPG variable, which we remember to be a transacted property group variable. We use the create property method, providing the name of the new property, and use that method to create TP, our new transacted property. Once we have the transacted property, it's just a matter of setting that property to a variant value in one of 2 easy ways. You would either use TP equals to some value in quotes. In this case, we set it to this sets a value, or this sets the value. Or and this is a typo on this slide, but you can fix it later, or we fixed it in the other slides. You would say TP.value equal to, and once again providing a variant value. In this case, quote, this sets the value also. So you could have chosen one of those two lines to set the variant value associated with the tspam property. So you see that you can manage state information if you choose using tspam by creating sets of property groups, providing in each group a set of properties, and then setting a single value for each property as a way to manage your information. It's worthwhile noting that as you're, it's a tspam and ADO, OLADB, DDL in IMDb gives you kind of two choices in terms of how you would like to manage your intermediate state in IMDb. If it's pretty simple and it naturally forms into groups of properties, tspam might be your best choice because it provides transacted cross-process access. In other words, other components can interact on a set of shared properties and be able to hold transactional requirements on those properties. If your information is more oriented towards, say, a traditional relational table kind of format, to store your intermediate information, you may prefer to choose ADO or OLADB DDL to create your own temporary tables in a traditional format, create indexes over that data, and use a traditional table to hold your sets of intermediate information. And the choice is up to you, whether you use tspam or whether you use IMDb temporary tables. So that concludes the slide portion of our presentation.